Okay, Chapter 8, Day 1. Today we're going to talk about confidence intervals. Or CI for short. So if we take a sample, and let's say our sample's large enough that our sampling distribution is normal. From the very get-go, when we introduced the idea of population values, mu, sigma, big N, from the very get-go I said that these are oftentimes numbers that we can't know, right? So how likely is it, do you think, really, in the real world, that we're going to know the standard deviation of a sample? I'm sorry, sample we can do. The standard deviation of a population, or the average of a population, the mean. How likely do you think that's really going to be? Or even the number of a population. Like, for instance, the number of people in the United States, that's changing all the time, right? Every time an airplane leaves and goes to another country or whatever, that's a constantly changing value. We can't ever know those exact values at any given time. So what statistics attempts to do is for us to estimate those unknowables. And that's what confidence intervals do. So mu, we'll never know. In most cases, we'll never know what it is. Okay? That's true for sigma and n as well. Now, what we can do, though, is we can come up with sort of a margin of error idea. If I put 95% of my data between two spots in my curve here, anybody remember how many standard deviations away from the norm is that? 2 and -2, right? So that makes our x bar 0. That's standardizing, puts it at 0. Now, what the confidence interval does is it tries to capture the mu of the parameter that we're looking for. And this would be considered, these guys here would be considered margins of error. I don't think that would be possessive. Sorry, margins of error. Now, in our last election cycle, I don't know how closely you paid attention to that, but you might have heard somebody say that candidate A is leading in this area, and we show that 46% of the likely voters are going to vote for candidate A with a margin of error of 3%. Right? So that means that anywhere from 49% to 43%, they think, is where the true population value lies. All right? So when they say that, when they say margin of error, it means they don't really know, but they're pretty confident that it fits between there. And that's where confidence intervals comes into play. So we are trying to capture a true mean The true mean is our mu value. That's a pretty ugly mu. From a sample mean. Now, the confidence interval gives an interval of plausible values. CI for short. based on a sample. Parameter is unknown, or in most cases unknowable. Now, a confidence interval can be any size you want it to be, but there are three common sizes that we'll see in this class. The three of them are 90%, 95%, and 99% confidence intervals. Those are the three common. Okay. So let's look at the 90% confidence interval first. If I have a normal curve, and I've got my sample mean for the curve, what I'm saying with the 90% confidence interval is that I think 90% of the time the true mean, or maybe I shouldn't say 90% of the time, it's not really a probability, that I'm 90% confident that the true mean falls between these values. Okay? And these interval values for 90%, something you'll see quite a bit. I would recommend, especially if you're going to take the AP Stats test, I'd recommend memorizing these. I'll put them up on the board here shortly, but these values will come up quite a lot. And so this is our 90% confidence interval. And what that's used for is when we're looking at stats that are not all that important. Okay? Like, what's your favorite flavor of Skittle? You can't have two. You can't have two, it's only one. What's your favorite Skittle? Okay. So we're talking about things that you're not going to get sued over if you're wrong. Okay, if your stats are wrong, you don't capture the true mean of the population, nobody's going to sue you over it. It's not life and death for anybody. Nobody's going to die if we say that the green Skittles are what the true population prefers when in fact it's orange. Okay? Yeah, it's not red or green, that's for sure. Okay? All right. Now, the 95% confidence interval, see if I can kind of try to draw that about the same. So I've still got my X bar here. 95 is going to be a little bit wider, right? So it's like a baseball mitt. I'm making a baseball mitt to catch balls. If I make it a little bit bigger, how am I going to be more successful or less successful at catching those fly balls as they come out to me in the outfield? Well, hopefully more, right? If my mitt is bigger, yeah. Maybe a tennis racket that's a little bit bigger, oversized tennis racket, if you will. And so these guys, what do we know these values to be? If 95% is in the middle, we know that it's about not 2 and negative 2, right? A more accurate number, although I think you could totally get away with 2 here, is 1.96. And again, those are numbers I'll put up on the board, but I would want you to memorize. Now, this one, this 95% confidence interval, this is the one where if if you're going to take some statistics into the courtroom, hey, I'm going to sue this manufacturing company because I've been buying sodas for them forever, and I took a sample of their sodas, and they didn't even put anywhere near as much soda in as what they advertised. I'm suing them. I'm going to sue them. Yeah, good luck with that. But this would be your data into court. There's probably some guy that's taking a sample of sodas off the line and checking to make sure that those sodas are being filled properly. Because if they're not, guess what? They can be sued. Okay? I don't know if the lawsuit would go anywhere, but they could be sued. Okay? So this is your law. The court is going to throw you out if you're not within the 95% confidence interval if you take data into court. Okay? They're going to go, nah, it's not a wide enough capture point. Your odds of something happening are too likely. Okay, and the last one, 99%. You can make them bigger than 99%. We just don't really deal with them in this class. So this is your 99% confidence interval. This has a value that you wouldn't find exactly on table A. This is 2.576 and negative 2.576 standard deviations away. So that puts 0.5% in each tail. This is your life and death. I'm making a new drug. And I want to make sure that that drug doesn't harm the people that take it. So I need to be at least 99% confident that the true mean, effects of the drug are captured within this reasonable amount, whatever that is, between those. And we'll see some examples along those lines, I'm sure. So if you're asked to choose one of these, are we talking Skittles? Are we talking a day in court? Are we talking life or death? This is how you choose these. This is how I choose them. Okay? What's the one that comes up the most often? The 95%. Okay, that's the one that you probably want to default to generally. Okay. So far so good? Okay, so let's talk about what this is sort of really doing. Everybody got this? Yeah? Okay. Real quick, this is our last graphic. So this X bar at the top, this thing has a name. In this case, it's our point estimate. It's still our sample mean, but it's our point estimate for the parameter that we're trying to make a guess about, or not really a guess. So let's go back to the 90%. If my z-score is 0 here, and this is negative 1.645, this is 1.645, and I've got 90% between here. Let's call this A and B. So the A and the B would be some real values based on context that we would have in a problem. Okay. If I take one sample and I get this confidence interval, then I'm 90% confident that the true mean falls somewhere between there. But what that really means for us is I can't find the true mean. But if I keep taking sample means, that I keep taking samples of the same size from the same population, most of them should be pretty close to the mean that I get here, right? But we've already learned that there's difference in different samples, right? Not all samplers are going to come up with exactly the same answer. So if I keep taking samples, what I can expect is that in a 90% confidence interval, 1 of the 10 will fall outside of the interval. Most of them will fall within this, but 1 in 10 will fall outside. If it's a 95% confidence interval, then 1 in 20 is going to fall outside. And if it's a 99% confidence interval, and I do 100 samples, how many would I expect to fall outside of that interval? 1. Right? 99 of them will be in, 1 of them will be out. Okay. So how often are we going to capture the true mean? We think that we're going to capture the true mean about 90% of the time. So we are 90% confident the true mean falls between, let's call it A and B, whatever those values are in your context, A and B. And that's how we would answer a problem. It's a confidence interval. This is the next big idea. Yes?
Did you say 1 out of 20 falls in between 95?
On the 95, yeah, 1 out of 20. So that's 5 out of 100, right? In this case, 9 out of 10. Sample means. Are expected to fit in our confidence interval. So I fear that that's giving you a taste, and it's probably not giving you enough to really maybe do these problems justice, but give them a try, give them a look. When you come back, we'll go over more. But I want to get you going on the test. So see if you can absorb a little bit of that.